Well, thank you for coming back from the break. And our first presentation is game management affecting population structure and hence male-male competition for mates also influence antler development in red deer. The abstract is on page 5 of the proceedings. Dr. Juan Carranza from Spain and his other authors also from Spain.
Thank you very much, Steve. All of us know that the antlers of deer are hunting trophies, yeah? But they essentially are not trophies, but sex traits. And as such, their expression is influenced by the cost of the production, the condition of the animal, the environmental factor, etc. We know many things about that. We have a lot of information about the influence of the condition of the animal and the environmental condition on the production of the sex traits, not only in antlers of deer, but also in many, many sex traits. But also, the expression of sex traits should be influenced by the expected benefit. That is, how they must use these traits to achieve reproduction. We have very little information about that. And this is the focus of our work now. We studied the red deer, the size of the antlers. That is a costly and plastic sex trait. And we also study the wear of teeth, tooth wear, because when they produce antlers, they need to get food. They need to process the food, and they wear their teeth. And tooth wear is essential for longevity in ungulates, in ruminants. And we focus on Iberian red deer. Our study area is in Iberian Peninsula, in the southwest of the Iberian Peninsula, in southwest of Spain. There we have the opportunity of using something like a natural experiment, because we have hunting states with different management types. Some of them are fenced by very high wire fences, and others are without fencing. Without fences. And the population of deer inside these different types of states is very different, because in open states, in areas without the fences, there is something like the tragedy of the commons. That is, one manager, one owner of the land cannot let the deer to reach a very high age, maturity, because the neighbor will hunt before, because the deer is moving between the properties. And then the result is that the population there in open areas is composed by few and very young males and many, many females. But in the fenced areas, the population is much more balanced, with a structure more natural, even despite the area is fenced, okay? If we look at the distribution of the hunted animals in these two situations, two different types of management areas, we can look at this part with the distribution of males in both areas, and the distribution of hunted or culled females in both areas. We can see how, for males in unfenced areas, the average age is very low. Most of them are about 2 years and no many more years. And this is very different than the situation in fenced areas where the age of the male is much higher. And for females, we have a very similar area, similar distribution in both types of management areas. So there is a clear difference improved by using genetic methods, looking at the paternity of males in this population and see how sexual selection is more intense, the opportunity for sexual selection is higher in the population with high competition compared with the other population. Okay, so then the hypothesis under these two different types of management regimes is that males under the low intersexual competition will develop smaller antlers because they don't need big antlers for to get harems of females, because they rarely fight with other males, because it's very easy to get to females, okay? And this is a possibility for them to save resources for next year, for instance. And as a consequence, if we look at the wearing of teeth, we will see less tooth wear in males and in the situation of low competition and longer expected lifespan that is related to the wear of teeth. Okay. We got data from many animals from different areas, more than 6,000 females and males, Iberian red deer, in 56 population with different regimes, fenced and open areas, in a number of years, with obviously a lot of people collaborating in that. And we use the typical linear mixed effect regression models and controlling for factors and random source of variation, etc., as normal, okay? So, going to the results. First of all, body size, body mass. For body mass, we already found a difference between males in the high competition situation and the low competition situation, but not for females. Body mass itself is a sex trait because they use the mass for fighting. So the increase in body mass is important from the point of view of sexual selection. So this itself is a result. But also, even if we do not find a result in the antler itself, the result could be relevant only with the body size. But even controlling for body mass, we found an effect in antlers. So even controlling for body mass, the antlers were larger, bigger, for males in the situation of high competition compared with the situation of low competition. Also for teeth, okay, we measured the height of the molar, the first molar, and obviously as they grow, they reduce the height of the molar because of the wear, okay? They reduce in general, so all the lines are in a slope, in a negative slope, okay? It's clear, it's obvious. But you can see the female case in the middle, the females in both populations are very similar in the relationship between the molar height and the age. But for males, the situation is very different. You see the males in the low competition areas here with very little wear compared with the males in the high competition areas with strong tooth wear. But also, because we are treating correlational data, it is possible that because of the intent hunting, if hunters select males of 2 years or so, because legally they can shoot the males above 2 years, if they select males with bigger antlers, the effect that we are finding could be produced by that, because they are harvesting the male with bigger antlers, and the remaining males are with very, very small antlers, okay? So for that, we look at the difference between high competition and low competition situation at 2 years of age and 3 years of age. If that were the case, we should find an interaction, a difference in the slope of these two lines. Because if they are selecting at this age the males of bigger antlers, then the difference will be bigger here compared with here, okay? So the interaction should be significant, but the interaction was not significant. So there is no evidence of selective harvesting of larger antlers in low competition compared with high competition. But even so, the correlational data cannot tell us about the real cause of the things, but only the association between them. So we need an experiment, and we did an experiment. So we get the collaboration of a deer farm, and in the deer farm, we used 200-something individuals, males and females, in different separated plots for 2 years of study. Males was 4-year-old males, all of them, the same condition in rating, the same appearance, etc. was plotted in one case with rival males. Yeah, in one plot with rival males. And in other case, 6 plots, 1 male with about 20 females, okay? This the difference. This is a picture of the plots for 1 male with females, and this the plot with the 18 males. This is the situation resembling the field situation of high competition, because many males without females, and this resembles the field situation of low competition, because 1 male alone without rivals and with many females, so very easy for him, yeah? And 2 years for replication. And the results. The difference in antlers was significant. The difference was about 5%. But think that we get this difference only in 4 months, because we put the males when they cast their antlers, and during 4 months of antler growing, the difference was significant and about 5% between one and other group of the treatment. Okay, so the conclusion is that the sex trait, the antlers, has been affected by the social environment. The males under low intersexual competition produce smaller antlers. And for senescence, measured by the wear of teeth, males in population with female biased sex ratio, where they can breed. Okay, the males can breed there. They copulate with the females, but they don't compete with other males. That's the difference. It's not reproduction, but it's male-male competition. What is producing the effect, okay, of delayed senescence by delaying tooth wear. So the implication of this study in 2 areas. One area is about the evolution of sex traits and also the evolution of senescence. For that, we see that there is a plastic modulation of the sex trait based on the expected benefits that is very rare in the literature. What we found is that social environment affect the development of the sex traits and the cost related to the development of the sex traits, okay? But also, on the other side, there is an implication for our action of management. By management, we are changing natural processes. In this case, natural processes related to sexual selection, that is a part of natural selection. So for the conservation of natural selection, our management can be affecting this trait. So if we know something about how natural selection maintains the organism, we will see that it's impossible to maintain this trophy without maintaining the sexual selection. So management should be changed. And when we get, for instance, by trophy hunting and so, we get trophies, we should value more the trophies that are the product of sexual selection than other trophies, for instance, from farms, etc. Thank you very much.
Okay, we have a few minutes for questions.
Thank you very much for this very interesting study and a very nicely performed experiment. I have one question here, and that is, well, this was a phenotypic plastic response. So, and the good question is, okay, does this really influence selection? And I guess here the prediction would be that over time, then at least deer in fenced population, they should develop larger antlers, or rather perhaps there should be selection for smaller antlers, or perhaps also smaller body size in unfenced population. So my question is, for how long time have these fenced populations been fenced, for how many generations? Because I guess that must be the next analysis, that is to analyze, well, long-term changes inside and outside these fences.
Yeah, we don't know how many generations, but so far the areas in Spain has been fenced since 30 years ago or something like that. So what we found in this population is differences in the genetic variability, in the homozygosity, and these kind of things. But still, we don't have any data about selection. We have a project now for that. So we are trying to look at that, look at the level of selection, looking at the region of the genome that can have signatures of selection. We are doing that now. So I don't know if we are going to find something, because the number of years and the number of generations probably is still low.
But do you by any chance have, for example, data on skeletal size over time? Skeletal size, for example, jaw length. Yes, because that should be a good measurement of size, body size per se.
Mandible size.
Yes, for example, do you have that generations back?
I don't know.
Okay.
I don't know if we have data for that, but simply my response is that we didn't analyze yet.
Thanks.
Hello, Juan. I have one question. When I was reading this paper, I was thinking quite a lot in the experimental part, in the works by Rodolfo Ungerfeld, that I don't know if you know. He was doing a very, very similar setting with just group of males and group of single male with females. And the results were totally the contrary. So he was finding in different parts, in antler size and antler quality, and sperm production, and testosterone, and I don't remember if something else. And it was all suggesting some female effect, that in fact the presence of the females was stimulating much more this part of the investing in the sexual trait. So I don't know, are you aware of all this work?
Unfortunately, I don't remember now the details of this work. So difficult to imagine some reason for the difference in the results.
He was suggesting all these papers with this female effect, that the presence of the females was really stimulating the animals to invest in the sexual trait. Yeah. While in the other high competition, it was like, okay, so why to invest so much in something when the competition here is so high? So, and maybe I have if I may, second question. You were showing in the correlational part, in the study, in the field study, data on antler length. Mm-hmm. What about antler weight? Because
the problem is that it's different to weigh the antler, because they are trophies, and the hunters.
That's right. It's not.
And in the farm, the problem was different, but the weight also was difficult to take, because they cut the antlers when they finish growing. If you wait, you will wait only the part that they cut, without the part that some near the pedicle that they left there. So,
right.
No, because it's difficult. So we decided to use linear measurements.
Differential investment in, not only investment in growing a large antler, but maybe making it smaller, but in higher quality, so it will be more resistant for fighting and this kind of things.
Another question will be the composition of the minerals that are in the antlers. This is another step, so probably interesting to do, but not done yet.
Okay, I think that's about all our time. Well, one more minute. I'm going to ask a quick question. In the initial analysis, were you able to control for the quality of the nutritional environment between the fenced and unfenced properties in the earlier study?
Not directly. We have some information of some of the states, not all, because there are many, some information, but not detailed analysis of the environment, but an index of quality general, and was not different in that case, but it's not very precise. But the main control, I think, is the data from the females, because the females are similar in weight and in tooth wear and everything, and they live in both environments. So this is, for me, it's a good control, females, because the other measures are debatable.
Okay. Thank you, Professor. Well, one more question.
Thank you. Maybe you mentioned it already, but how do you determine the age of the animals?
Yeah, cutting the first molar. We cut the first molar and look at the microscope the layers of the cementum layers growing in the under radicular pack. You know. Thank you very much.